In this video I'm going to take you step by step through how you use Kirchoff's laws. First step is always to model, so let's draw our circuit. In this case the circuit looks like this. Remember to draw it nice and big, you're going to want to annotate it. Now we do the whole modelling process. So which areas are at the same voltage? Well, this whole top area is going to be at the same voltage, so call that, I don't know, V1. The bottom area to there is going to be at the same voltage, we'll call that V0. And there's going to be a V2 in the middle. Now draw currents. Now you may not always know which direction the current is going to flow. If you don't know, just guess, and if you got it wrong, you just come out with a minus sign. In this case, for example, depending on the relative voltage of these two, the current could go either way through here. Anyway, let's call this one I1. And we'll call this I2. I'm guessing it goes upwards. And we'll call this, now you can either call that I3 and then solve for it later. What people often recommend is use Kirchoff's junction law right away. We know that this is a junction, therefore the current in must equal the current out, so this must be I1 plus I2. And that saves having an extra variable. Now this is going to be bigger than these two because it's the sum of them, so I'll draw it nice and thick. It's going to be I1 plus I2 here, I2 through there, and I1 through there. Okay, so we've drawn everything. Now let's use the voltage law, Kirchoff's second law, around a few loops. Now we could have a choice of loops. We could have this as our loop, or this as our loop, or this as our loop, all the way around the outside. Two of them will be enough in this case to solve everything we want. The third is just icing on the cake or a test. I always like to sketch what's happening first. So let's go around this loop. Pick a direction. I'm going to pick clockwise. It doesn't matter which you pick as long as you are consistent. So I'm going to go clockwise around this loop, and if necessary around the outside loop. Around here, what's the voltage going to do? Let's draw a diagram. So we're going to plot the voltage against position as we go around this loop. So it starts off at V0. Then it's going to go up. Let's call that VA and VB. It's going to go up by VA. And then it's going to go down by VB, which I've assumed is smaller than VA. Remember, the voltage always increases from the minus side to the plus side, so the voltage must go up here. And we're going around our loop clockwise, so it goes up here. And this way we're going clockwise from the plus to the minus, so it goes down. And here, the current we've had flowing upwards, which means this must be at a higher voltage than that side. So it's going to go up. The voltage here must be higher, so it's going to go up by I times whatever this is. Let's call that RA. I2 times RA. Now right away, for consistency check, we can see this has come out wrong because the voltage here can't add up what's there. So in this case, it can only work if either the current is going the other direction or if VB is bigger. Let's assume VB is bigger, so in fact it will go down to here and then go back up like that. So VB is bigger than VA. Around this loop, what's happening? We've got the voltage. Let's start here. It doesn't matter where you start. In this case, we're going from plus to minus, so the voltage is going to drop by I2RA. Then it's going to go up by VB. And then it's going to go down here because we're going from the plus to the minus. It's going to go down there by, let's call this RB. Let's go down by RB times the current through it, I1 plus I2. If we did the outside loop, we'd have it going up by VA and then down by this. So what we can now do, we've now looked at what's going on. Be very careful. Remember, the voltage is always highest at where the current goes into a resistor and lower where it goes out, whereas for a voltage source it always increases from the minus side to the plus side. Make sure you get that right. What we can now do is write down these equations. So let's take the equation for the outside loop. That's a nice simple one. So we've got it, voltage goes up by VA and then goes down by RB I1 plus I2, and that must sum to 0 because it takes us back to where we started from. And let's say pick the right hand loop. In that case you've got minus I2 RA plus VB minus RB I1 plus I2 equals 0. And if you want the left hand loop, you're going to have VA minus VB plus RA I2 equals 0. So you've got a bunch of simultaneous linear equations and you solve them for whatever you need to know.